Welcome back to Cyber Professor Richard, continuing our friendly intuitive learning. And we're going to be completing our introduction. Shakespeare in the play Macbeth said, "What's past is prologue." And what that means to us is that our role as cybersecurity professionals, that's whether you're new to the field, want to learn about it, see if it's something for you, if you've been doing it for a little while, or you're a seasoned professional, there's always something to learn. And what I found is not only do we have to understand today's information technology infrastructure, but to be best positioned as a cybersecurity professional, we need to anticipate the future so we can prepare for it. And when it comes along, we're ready to address it. So let's take a look at that, because what that will provide for us is our path for a bright and successful future. So we're going to look at a very brief technological history, broad strokes over a few centuries, to kind of just get a flavor for it, maybe have a little fun. And then we're going to see just two smart guys who got it right, who made some predictions that are so important to us today. And what that's going to lay out for us is challenges we face, and most importantly, why we'll succeed. So let's look at some history. Now, in putting this together, I looked at industrial processes and what programmatic controls were introduced and when they were introduced. Now, when I did my research, I saw references to ancient Rome. There were claims that the ancient Romans did programmatic control of their processes, but it was never found an example. If anybody can, please email me that example. I'd love to incorporate it. But what I do know is that Joseph Marie Jacquard, which was a French industrial weaver, introduced programmatic control to these industrial looms at the beginning of the 19th century. About 1802 or 1803, he first introduced them. There's some excellent videos on this that you could Google and watch. They're quite fascinating how this was done well over 200 years ago. Okay. And they used 40-column punch cards, which were the precursor to the punch cards used, into the 1950s, probably till the 1970s, or even later at times. But this was really, for the first time, programmatic control of an industrial process. Now, two decades later, Charles Babbage, brilliant inventor, came up with this idea first of this difference engine, which was a mechanical calculator. Think about that. In the 1820s, he came up with this idea, and then further sophistication with the analytical engine, which turns out to be the design programmable computer in the 1820s. He's probably known, you've probably heard that. What you may not also be aware of is that Ada Lovelace, who was the daughter of Lord Byron, the poet, knew of Babbage and worked with him and came up with the concept of, writing programs for this device. Now, it turns out that Babbage was a brilliant designer and a really terrible engineer. He was paid by England to build a machine. He was never able to do that. Now, towards the end of the 19th century, a couple of guys got together using materials that were contemporary to Babbage's time, was able to construct the analytical engine. There were minor errors in the design, but nothing substantial. It was a brilliant design. He never lived to see it actually implemented, though. Now, towards the end of the 19th century, to step back, the United States, through its Constitution as a representative republic, requires a census every 10 years. In 1880, the census took 8 years, and folks got worried. If the census goes beyond 10 years, we've got a real problem, because in order to represent the population, you have to know what the population is. And so Herman Hollerith took the concept of a punch card, expanded it to 80 columns. This is from the Jacquard loom. And there was a bake-off, 3 finalists. Herman Hollerith was one of them, was able to perform the census in 3/4 of the time. He beat out the 2 competitors by an order of magnitude. He was really 10 times faster than they were. And what's interesting is he won the contract for the census. The Hollerith design was used for the census until the 1950s. And in the 1950s, early 1950s, the U.S. Census Department purchased the first commercial computer, the UNIVAC 1, to supplant the Hollerith. Now, what's interesting also is that the Hollerith company that was created morphed into the IBM company in the early 1920s. It was merged in, right, to only be supplanted, in a sense, by another computer company, UNIVAC, for the census. Now, where it gets probably more interesting, and you probably all heard the story of Enigma, which was the German code used during World War II that was cracked by computers that were designed by Alan Turing, had a profound impact on World War II. The cracking of Enigma probably saved 20 million lives and shortened World War II by 2 years. But now the concept of the digital computer was fully born now. And you can look at the history. It was first, then after World War II. Now, Enigma, the project that cracked Enigma, was really classified until the 1990s, but word got out, the idea of a digital computer. So here is this history. Now, we're going to come to found inflection point. Tim Berners-Lee was a physicist at CERN. CERN is this collider that is underneath France and Switzerland, right on the border. And in the 1880s, they were, accelerating these subatomic particles at extremely high velocities and smashing them into each other, which created an enormous amount of data, literally terabytes of data in the 1980s. And so the question was, the purpose of CERN was to share this with the world. Well, how do you get out and get that much data out to all these scientists all over the world? Well, the internet, which existed at the time, was relatively slow, but even today's internet, to be sending out terabytes of data all the time, every time they do an experiment, was not feasible. So Berners-Lee came out with this brilliant idea of taking the concept of hypertext, which had really been born in the mid-1940s, the idea of hypertext, of referencing something within a document that was another electronic source. And he came up with this idea of the World Wide Web, which was a client-server model. So CERN would be the server. The data would remain, for the most part, at CERN, but the scientists all over the world would be able to access the data and have the servers at CERN do some of the manipulation, but the control and presentation would be at the scientists all over the world through this idea of the World Wide Web. Really brilliant and profound. Now, another major invention was through Rivest, Shamir, Adelman. Those are the three guys, and there they are. They created RSA, which is public key cryptography, and it's embodied in the protocol and really supports the protocol of PKI, public key infrastructure. And we'll see how significant these are in later presentations. But this trajectory, moving forward within 2 centuries from this idea of programmatic control of industrial processes, to really what we see today, which is, as we'll see, the internet everywhere. And let's take a further look at that. All right. And we're going to look at 2 brilliant people who predicted the future and did it quite accurately. First is Marshall McLuhan, who is a Canadian philosopher and futurist, a really brilliant guy. And I encourage you to Google McLuhan, see some of the videos as well as written work that talk about him. So he came out, and he's quite famous for this. The new electronic interdependence recreates the world in the image of a global village. And that was in 1962. And when you think about that, 1962, well, there wasn't an internet yet. There were some telecommunications connections, but they were quite slow. I mean, I go back that far, and we were talking at 10 characters a second. Think of this screen that's being painted in front of you as you watch this video. Right? We're talking, all right, megabits at least. At 10 characters a second, you'd be here for quite a time just to see this one screen. But he recognized that this was coming. Think about that. He recognized that this was coming. That's quite important. Okay? Now, the other thing, and we'll be looking at this later on in later presentation, is the other change was that how information is presented was changed from typically just written words that you would, go to the library and get a book out and read it, to instantaneously being able to connect with events all over the world and people's ideas all over the world, essentially instantaneous. So think about that. Now, if we step back and see a bit of history here about Gordon Moore, who's a co-founder of Intel. Intel is a company that makes semiconductor chips, essentially microcomputers. Okay. And what happened was John F. Kennedy, President of the United States, proposed this idea, which was adopted by Congress, taken by the creation of NASA. NASA was created before Kennedy came up with this idea, but NASA was put to work to put a human being on the moon by the end of the decade, the 1960s. And indeed, in 1969, an individual was put on the moon safely and returned to Earth. Now, how do you do that? All right, well, you need a computer to navigate. You need a computer to control the various instruments in the spaceship, in the space capsule. Well, before this space program, the Apollo program, computers were getting bigger and bigger. Well, the big challenge of putting a human being on the moon is getting him to the moon. In order to get him to the moon, you've got to build a rocket and fuel it. And since you've got to escape Earth's gravity, you need a lot of fuel. And so putting a computer that weighed tons, and that's what it did at the time, into a rocket, wasn't feasible. So computers, instead of getting bigger and bigger, now had to get smaller and smaller and more powerful. And so Gordon Moore co-founded Intel to produce computers that would get smaller and smaller. And of course, this has enormous implications for us today. since computers are smaller and smaller and cheaper, they're everywhere. And what Gordon Moore recognized, I think it was in 1965, he saw, because he really understood the technology, that for the same cost, computers were doubling in power every 1.5 to 2 years. Or another way of looking at it, for the same size, which was on essentially a silicon wafer, you can get twice as much computing in the same area. And what are silicon wafers? Well, they're made out of silicon, obviously. Where is silicon? Well, go outside and dig up some dirt. Half of that is silicon. So silicon is everywhere. All right. So this is quite inexpensive to make computers. Designing them, of course, is a different question. Once they're designed, they're very inexpensive to fabricate. Okay. And so this is Moore's law. Now, what's interesting on this chart is this really goes back to the beginning of the 20th century. And you can say, well, wait a minute, that's just linear. It doesn't look so great until you look at the ordinate, the y-axis, and see those are powers of 10. So this is a logarithmic scale. This is exponential growth for many decades now. Brilliant insights by both of these people have laid the groundwork for the challenges before us. Their prescient predictions are now our abundant opportunities because there is so much to protect. This has created such incredible value. Whenever we have something of value, what do we have? We have bad guys that either want to steal it or in other ways impact it. And we're the folks that are going to protect it. So let's look at that. Let's look at that magic and the opportunity of cybersecurity. And it's built, of course, on the foundation of information technology. It's looked at, has a remarkable history for the last 2+ centuries and remarkable growth over the last several decades, which create these enormous opportunities for us. Where is information technology? It's everywhere. Your watch, the computer I'm using now, the computer or cell phone you're watching this presentation on, okay? Your TV, your car, your thermostat, your washer, your dryer, your refrigerator, your toaster, your oven, and so on and so on. The traffic control systems, airplanes, ships, defense systems. We could go on for hours, days. So the internet is this omnipresent highway for good. It's brought enormous wealth and value and standard of living to so many people. On the other hand, it's also, as we know, a highway for evil. And that's our challenge. It's, of course, our opportunity. This value, as I mentioned, attracts criminals. Imagine people who would create a ransomware attack against a hospital and put people's lives in jeopardy for money. That's what they're doing. We have to stop them. And we will, because we have advantages. Okay. We've trust. We're the good guys. We can trust each other. That's so important, because that means we can work together cooperatively. Best minds can work, come up with the best solutions. We cooperate. And we have the discipline. You have the discipline now, as you're watching these videos, to learn, become better and better. So please subscribe and follow the channel. You want to correspond with me? Cyber Professor Richard, that's my channel, and here's my email. Please be happy to hear from you. I will respond to every email I receive.